Hello, this is Coach Myanmar for AP PreCalculus. We are doing 2.13 exponential logarithmic equations and inequalities. So we get lots of algebra skills going on here, which is totally fun. Let's just get at this thing. Okay, so solving exponential equations and inequalities. So we have exponentials. A couple things we can do here. If it isn't a trinomial type of deal, it's not polynomial, but if it's got like three terms, there's a good chance that we can factor it somehow. That'll pop up. If we have two exponentials, we want to try to create the same base. So much easier to do that. Or last method here that it mentions here in the bullet point, to rewrite the expression. And we can use that sometimes whenever we have logs that are in the exponents. So let's see what we got for us, what challenges are ahead. Okay, so to solve for x right here, I want to rewrite this so that the exponential is by itself. So I'm going to divide both sides by 3. So I get 2 to the x plus 1 is equal to 8. Okay. You can rewrite this as a log if you want. I'm just more used to rewriting when I have an exponential equals to the exponential. You might be thinking to yourself, but wait a minute, coach, that's not an exponential. Well, can I make 8 have the same base as 2? The answer is yes. 8 to the third is the same thing. Once we have that, the bases are the same. That means that I just got to set my exponents equal to each other. So I'm going to get x to equal 2. Ooh. What's nice about exponentials is there are no domain restrictions, so I'm good to go here. For letter B, this one's a little bit weirder because it's got that log in there. Let me zoom in. Or maybe not. Okay, so we got that log in there, so I'm going to use my log power rule here to rewrite this as 3 to the log base 3 of 16 times x. Okay, and if you actually look right here, this log base 3, the bases essentially cancel out. And so we can rewrite this as a b to the x equation. So the new base is the argument, and then the x here goes along with it. So this is the same thing as saying 3. Actually, no, it's not 3 anymore because the bases cancel out. It becomes 16 to the x. Okay. So 4 to the 5x minus 3 is equal to 16 to the x. Now I need the same base. Can I break a 16 down? Remember, we can only go down. We can't break up. Break down a 16 to a 4. What's that? It does? Oh, it's just going to be 4 squared. Perfect. So 4 squared to the x. That simplifies here. I'll rewrite the left side, which is unchanged, and the right side is 4 to the 2x. Same base, set the exponents equal to each other. So 5x minus 3 equals 2x. If you don't mind, I'm going to subtract 2x on both sides. Why do I ask if you mind? I'm going to do it anyway. 3x equals 3. Divide both sides by 3. X is equal to 1. Again, no domain restrictions, so I am good to go. Next one here. We can't get the bases all by themselves because we have 3 terms. So this is that trinomial type of looking thing here. Like if this was x squared, let me write down a think. X squared plus x minus 6 equals 0. How would we solve for that? Well, this factors nicely. This would factor into x plus 3x minus 2. Okay, now we want to think that way for the e's now. So now I can rewrite these e's, by the way, as factors of each other. E to the x times e to the x gives me e to the 2x plus 3 minus 2. Okay. So now I'm going to set these two individuals terms, or factors rather, equal to 0. Now, in the previous two examples, I was able to rewrite the bases to match each other. Well, when I do this, e to the x equals -3, there's no common base that's going to happen there. Okay, when I rewrite the e to the x is equal to 2, there's no common base there, so that's not going to work out for us. So my advice, I'll start in the e to the x equals 2. Since there's no common base between e and 2, I'm just going to rewrite it with use my loop method. So ln of 2, remember that's log base e, which is the same thing as ln. So ln of 2 is equal to x, which is the x value I need. If you were to rewrite this, you would get ln of -3 equals x, which is not a thing. We can't have ln of negative numbers. Okay, so we are going to reject this. So we're going to reject that because we can't have an exponential equal a negative number once we're in the parent function portion of it, which makes sense because exponentials have a horizontal asymptote at y equals 0. So we can't ever go below 0. So if you ever get exponential equals a negative number, that ain't a thing. Can't do it. All right, let's move on over here to our calculator section. I mean, all we do for this here is we just type this in. So using technology, I'm going to type f of x into y1, g of x into y2, and I'm going to find the intersection. That's something that we should know how to do, but you never know. That's not what I want. Okay, so y1, I said that's going to be 3. I'm going to put a parentheses instead of a time sign. My calculator's okay with that. X minus 1 is what it says. Make sure you don't use the negative sign. If you use the negative sign, it's going to tell you that things aren't going to work out for you. Oh, no, this is 4 minus the negative sign minus 3 to the x. I'm going to hit zoom 6, the standard window, which will work most of the time. Oh, so I have red and blue that should intersect each other. How do we find out where they intersect? Well, if you hit this blue calc button, it has all the magic for us. So hit second trace, which activates the calc button. 5 is intersect. It's going to ask you 3 questions. It's going to ask you for the first curve, the second curve, and then the third curve. I'm trying to figure out if you can even see me right now. Can you even see what I can see? I have no clue. I'll find out when I publish this video. If not, oh well. Now, so hit second. Oh, wait. I already did that. Okay, so when first curve, answer that question, hit enter, enter, and then guess. There's just one intersection, so that's the only thing we need to do is guess. So right there is my intersection, so I'll write that down for you. So the intersection point right here, so I'll answer D right here is 0.542, I truncate, and 2.184. So that's the intersection point. Okay, when is F larger than G? Again, F. Oh, wait, that's Desmos. F is the blue one. Okay. So when is the blue one right here? Well, I guess they're both blue. I'll trace that. This is red on my calculator. When is blue bigger than red? That's going to happen from whenever x is bigger than their intersection. So 0.542. Okay. All right. Last one here, or last little section here. Not solving logs. Okay. Logs similar to exponentials is you want to get the logs by themselves. Okay. So to go ahead and do that, we need to use our log property. So for a here, this is the same thing as saying as log of 2x is equal to 1. And don't forget that this is like a power 10. It's not there, but it's hidden. So I'm going to go ahead and loop this thing. So 10 to the 1, which is 10, is equal to 2x. So 10 equals 2x. Divide both sides by 2. X is equal to 5. Same idea here in B. You want to condense this, so we just have logs on one side, or not one side, but logs, one log term on each side. So I'm going to get log base 2 of 6 over x minus 1 equals log base 2, put that in parentheses, of 2x minus 3. Since I have logs on both sides, those actually do cancel out. So I'm left with just the arguments. Oh, getting a little laggy here. And then from there, we just do some old school algebra. We're going to cross multiply. Oh, so 1 times 6 is 6. And then we got x minus 1. Oh, getting laggy again. 2x minus 3, and multiply that all the way through. And we're going to get 6 equals 2x squared minus 2x minus 3x plus 3. So I'm going to get 6 equals 2x squared minus 5x plus 3. And then this is a trinomial, so we're going to throw the 6 on the other side by subtracting by 6. Whoa, that is how my child writes. 0 equals 2x squared minus 5x minus 3. That factors 2x and x. So I'm going to get 3 is 3 and 1. So let's do this. This gives me a 6 on the outside, 1 in the middle. So let's go minus 6 plus 1, which means that I'm going to get x to equal negative 1/2. Ooh, let's write that down. Negative 1/2. And x is equal to 3. Now, something I should have told you before, I did not, neglected, is that logs have domains where the argument must be bigger than 0. So the argument must be bigger than 0. This is an argument right there. It needs to be bigger than 0. It needs to be bigger than 0. Okay, those are arguments. So if I were to plug in a negative 1/2, are both my arguments, or just really any of my arguments bigger than 0? They both need to be. No, so I'm going to have to reject x equals negative 1/2. Not because the x value is negative. I don't care about that. It's when I plug them into the arguments that I do get, oh man. These bills, you just raise up and wave. And I paid the electric bill back on. There we go. So we're going to reject 1/2. All right, do I reject 3? If I plug a 3 back in, both arguments, on the left hand, my argument's going to be a 2 when I plug in a 3. Then the right hand side, my argument is going to be a 3, which is totally fine. So I reject 1/2, but not 3. Okay? Last thing, using technology. Again, I really hope you can see the screen. If not, what a waste of time this video was. I know what you're thinking. It was a waste of time anyway. You don't know what you're doing. Be quiet. Well, only my wife can say that. All right, so for the first one here, we're going to go ahead and sketch this as log, by the way. You can make bases in your calculator by hitting alpha F2, and then go to log base, and then you can type in any base you want. So this is log base 2. If you have one of those older calculators, like back in my day, we didn't have a button that had a base. We had to use the change of base formula. And the second one's going to be ln. There is an ln button here next to the 4. ln of x minus 1 plus 3. Hit graph. So blue is going to be my first one. If you notice right there that you can kind of sort of see the vertical asymptote without there actually being vertical asymptotes. You can see that there's a starting point, kind of, sort of. These do intersect. Again, hit second, trace. Choice 5 is intersect. Hit enter 3 times. I don't know what's going on. I think the calculator froze. Hello? Oh, boy. Time to quit. No, quit the graph. Okay, here, let's try it again. Choice 5 is intersect, enter, enter, enter. Okay. My calculator here on the screen is breaking. I can just tell you what the answer is, though. Hopefully yours doesn't break too, but yours isn't on the school Wi-Fi. All right, so this actually intersects at, luckily, I already have this answer. This intersects right here at the point 1.4 2.5, that's me truncating. You can round or truncate. And then 2.145. So when is f smaller than g? Just to remind you that y2 is red. So it's going to be this one. Oh, no. There we go. It's this one right here. This is the red one, which is y2. So when is the red larger? Well, the red is going to be larger when x is bigger than the x value of the intersection. Okay, and that's going to wrap up that video. And don't forget to like and subscribe.